So 2-3 is where we are doing some word problems. So there's a piece of notes. I'm not going to write the first bit of notes on the board, but the general advice for word problems from this notes paper is: 1, draw a picture if it's helpful. If they're drawing a picture of something that's real world, like a field that's a rectangle or a table that's a rectangle, draw a rectangle. If they're describing something that's not real world and they're just saying like 2 more than a number is 6, it's not worth a picture on that. But draw a picture if it seems helpful because it's a geometry real world item. 2, for any story, you need to translate the English words from the story into math, into some kind of an equation. Solve the equation like we have been through the week. And then always for these word problems, try to translate back to English and think to yourself, does this answer seem reasonable? Okay? When you solve for x and you get x equals 8, that doesn't really have meaning if all you had to deal with was an equation with x's. But if I'm talking to you about how many feet a table is and your answer is -8, well, that doesn't make any sense. You can't have negative tables. If they're talking to you about how many miles a car is driving from Pittsburgh to Cleveland, and you come up with an answer like 12 million miles, well, it's pretty obviously not 12 million miles from here to Cleveland. So you want to think about that. Is your answer reasonable in the context of the paragraph that you were given? So I'm going to work 3 problems, okay, on page 65 in the book. Up at the top of the page, there's a problem that says try this. So TT for try this, problem number 1, describes there's a rope that's cut into 2 pieces. One of them is 3 times as long as the other. How long are the pieces? So I'm going to draw a rope because I can. I'm not the world's greatest artist, but I can sure draw a rope. And it tells me that the rope gets cut into 2 pieces. So right there, I make my little cut, snip, snip. We cut that rope into 2 pieces. It says that the whole rope before we cut it was 32. So maybe I draw myself a thing like this to label that that's 32. And then it says that there's one piece 3 times as long as the other. I don't know how long either of these pieces is for sure. I don't have a number for those. So they're both a little bit of a mystery. So these both have something to do with something with variables. I'm going to use x just because I've got to pick a letter, any letter. But if the one piece is 3 times as long as the other, one piece can just be x. The other piece should be 3x because it's 3 times as much. So little piece could be x, big piece could be 3 times x. If you got these mixed, it wouldn't really matter, but it would look a little weird. I mean, obviously this, from looking at it, is the bigger piece the way I drew it, so I made that be the piece that was 3 times x. So step 1, picture when it's helpful. Step 2, sort of done. We sort of translated some story to math stuff, but we need an equation now. We need to somehow interrelate these numbers. There's an x, there's a 3x, there's a 32. We need to describe sort of how they all go together. The relationship is that the little piece plus the big piece, if we put all the pieces together by adding them, it would equal 32. So step 2, mission accomplished. We've got an equation. Then we'll solve. Okay. Remember, there's an invisible 1 there. Combining like terms, 4x is 32. Dividing by 4, the x would be an 8. And then let's read and see what they asked. They asked, how long are the pieces with an S, plural words. There's multiple pieces, 2 pieces. So we need multiple answers. And sometimes our picture can help guide us. The x is 8. The x was describing the littler piece being 8. The bigger piece is 3 times that x, 3 times that 8. So that piece is 24. They want to know how long both pieces are, so we give both answers. And before we move on, we should just think, is that reasonable? They said there were 32 pieces, 32 feet of rope total, and those do add to 32, so that seems good. The one piece is 3 times the other one. 24 is 3 times as big as 8. That does seem good. I'm comfortable with that, and on we go. Second sample problem I'm doing on the same page, 65, just in the middle. There's a problem called try this number 2. Try this number 2 says 7 times a certain number is subtracted from 6. The result is 5 times the number. What is the number? Well, for this, there's no picture to be drawn. There's no real world item they're describing. This is just general, generic sort of stuff. So what we need to do is just read this sentence a word at a time and write math symbols as we go. So if doesn't matter. 7, we know, times a certain number. So we're multiplying by a number. We don't know what that number should be. So 7 has to multiply a variable. Is subtracted from 6. If this is subtracted from 6, we're not going to go minus 6. If it's being subtracted from 6, 6 is back to the beginning. This thing is subtracted from 6. The word is generally is an equals. A moment ago when I saw the is, I was tempted for a second to do an equals where we already had an is, but is subtracted from, that's a little different than just a flat out is. Right now we've got result is, that's the equals, 5 times the number. The number we had previously decided to call x, so that's where we are. So one word at a time. 7 times a number was subtracted from 6. Result is 5 times the number. We're good. And it's solve time. There's x's on each side. We need to get rid of one or both of those. I wouldn't get rid of this one because then you empty that side and that's just a little awkward. I'd get rid of this one. To get rid of a negative, we look to add 7. So adding 7x to this, we come out with 12x. 12's multiplying, so we divide. If you divide by 12, that puts 12 on the bottom. 6/12 is okay. Better answer than that is half. And this is a problem where you can't really do the is this reasonable? Like there wasn't really like a great descriptive story there. We're just dealing with numbers. That could have been any kind of number, big, small, negative, positive, fraction, decimal, who knows. So we just go with that and move on. Up a page to 66. 66, there's a try this number 4. Try this number 4 is a little different than the other two. There isn't really even an equals in this sentence, and you'll see what I mean when I read it. It says the county cab company charges 60 cents plus 11 cents per kilometer as the fare. And they ask you what's going to be the total cost of 11 cents or of 12 kilometers. And you're coming up with a money amount. There was nowhere in this that they had an is or an equals or a total or anything else. So there's going to be some stories in tonight's where you're just going to have like almost like a 7th grade story problem to try to solve. Just add, subtract, multiply, divide. But there's no dead giveaways as to like exactly what they're doing other than the word plus, I guess. So what you'd want to think about here for number 4 is the different things you're paying for. Are you paying for one of them, or are you paying for a bunch of them? Okay, I don't know if any of you have ever ridden in a cab before or paid for much stuff in your life. A lot of things you pay for, there's like a basic charge you pay one of, and then after that you pay per unit. Parking garages are a little bit like that. You show up, you pull in, it's like $5, and then every hour they up you $1. Taxi cabs are like that. They show up, they charge you, and then you drive farther, they'll charge you more. People that work, trades for a living are like that. An electrician shows up at your house, it's like $100. And then every hour, 50. Or somebody's gonna fix your car. They charge you a base amount to show up, and then charge. This number 4, the 60 cents, you're paying once. The 60 cents is what it costs you to just get in the cab. If all you do is get in the cab and then get right back out of the cab, and all you did is put your bag in the trunk and take it right back out, they want their 60 cents for this story. Then we're paying 11, lots and lots of 11s. The 11 cents you're paying 12 times because you rode 12 kilometers. So we need to do 11 times 12. That makes a 132. They threw the word plus in there. We take the 60 plus the 132. We're getting $1.92 off of that. that's not very reasonable in $2,021 for renting a cab, but they just didn't put reasonable numbers in the story, so that's why that sort of fails that test. Where we are for homework is 67. 67, we're working from 1 to 8. And 1, 2, 3, 4 are like the rope cutting question. So 1, 2, 3, 4, we're doing pieces of rope. I noticed one quick difference even as I flipped through that. If I go back to my rope story and I said there's 2 pieces again, instead of 1 is 3 times as much. If I said 1 piece is 3 more, I'd have gone X, I'd have gone X plus 3. So that's a possible thing I see happening in at least one of those stories. If they say 1 piece is 3 more than the other, that would be how I'd call my pieces. If they said 1 piece is 3 less than the other, I'd have done something like that. If they said something like 1 piece is 1/3 of the other, I'd go with maybe like a big X, and then the littler one be 1/3 X. So that's how you label the pieces if 1 piece was 1/3 of the other piece. The equation for all that rope wire things though for 1, 2, 3, 4 will be 1 piece plus the other piece equals a total. So like this plus this equals 32, or this plus this equals 32. When fractions get involved, it's up to you. If you want to clear the fraction like yesterday, fine. You want to live with the fraction, that's fine. That's your call. 1, 2, 3, 4 is like try this one with a couple of those twists. 5, 6, instead of taxis, you've got other things going on, babysitters and rug shampooers. You don't need an equation for 5 and 6. You just need to like do the math. 1 to 4, you want an equation and some work and a solution. 7, 8 is more like this, try this too. Patiently read the story. Each word means a math symbol. Solve it up, but the answer isn't going to really have a meaning. But 1 to 8 is all we're doing today. Tomorrow we're another section here. Some different example problems for some different types to continue in 2-3. So 2-3 part 1, that's a wrap. Do the 1 to 8.